Hey everyone at home, we are finally done with chapter 5, which is one of our hardest chapters, and we are also finished with string art. For those of you who are at home, everybody's string art is due on Monday when they return after the weekend. However, you guys obviously have extra time, and we can work things out when you get back, so don't worry about that. Okay, so our new chapter is not dealing with one line, but 2 lines. And that's what we call a system. So we're going to start by talking about kind of what a system is, how to solve it, and there's a bunch of different ways of solving it, but today's goal is to solve the system by graphing. All right, so first off, it is formed by, so what makes something a system of linear equations? We have 2 or more linear equations. Basically, 2 or more lines is what a system is. Now, in algebra this year, we are going to only have 2 lines. But the higher levels up you get in math at the high school, you might do 3, 4, 5. It just gets more complicated as you guys start knowing more about the math system. All right, so what a solution of a linear equation? It has to be, you guys are used to solutions of equations where it's like x equals 5, and that's your one answer. Well, it's not just x, we actually need an ordered pair. That makes the system true. So an ordered pair that makes not just one of the equations true, but both of the equations true. So we need what x equals and what y equals. Usually we don't write it like that though. Usually we'll write it as x comma y as an ordered pair, like said above. All right, so we're going to learn 3 different ways of solving it. We're going to start with the one that you have learned in 7th grade. You guys have learned how to solve a system by graphing before. So we're going to start with what you know, and then we're going to get a little bit trickier. We're going to learn how to substitute to solve, and we're going to use how to eliminate. Now, the bottom 2 are the ones that are used more often. However, like I said earlier, we're going to start with what you know, which you know how to graph lines, and so we're going to learn how to find the solution to a system by graphing both of the lines. All right, so here is our first example. So we have this system that's been given to us. I'm going to graph the first line in pink here. So remember, always graph your y-intercept first. So 2, the slope is 1, so up 1, right 1, up 1, right 1. So that is the slope of that first line. Now, when we were in our last unit, we said you only had to do about 3 points on the line. In this unit, you definitely want to put more points on the line, and I'll show you why here in just a second. Okay, so now I'm going to graph the second one. I'll put it in purple. This time the y-intercept is -2, so I have to go down 2. And then I'm going to use my slope of 3. So again, rise over run, up 3, right 1, up 3, right 1. And I'm going to connect my points there. And the reason why I need to put as many points as I can on this line is because the solution, in other words, the ordered pair that makes both of these equations true, is the point where they intersect. So that point right there. Now, the most common mistake here is people think slope. So they think the answer is rise 4, 2. So they'll say 4, 2. But that's not right. Remember, when we name a point, we name the x comma y. Okay, so we find our x-axis, that was 2, and 4 on our y. So it's 2 comma 4. So be careful with that. Naming a point is different than the slope of your point. All right, so let me explain what I mean by it makes both equations true. So if I plug in y, which is 4, and I plug in x, which is 2, I should get a true statement. Well, 4 does equal 4. That was true. And not only should it work for just one, it should work for the other one. So plug in 4, 3 times x, which was 2, minus 2. That would give us 6 minus 2, which is 4, and 4 does equal 4. And kind of the cool thing about this is that there is only one point that is going to work. Like that point 2, 4 is the one and only point that makes both of them true. That's why it's so special. Okay, so let's practice a few more now that we kind of understand the process. Okay, we've got our system here. I'm going to graph the first one, this one, in blue. So I'm going to go down 4 to start. My slope is -1, so I should go down and to the right. Well, that goes off my graph. So I need to do the opposite now and go up and left. Again, try to get as many points as you can, preferably on the graph. All right, the second one is tricky. We don't really like to graph when it's in standard form. Now you can find your x-intercept and your y-intercept, or a lot of you guys like to rewrite it and put it into slope-intercept form. So that's what I'm going to do here. I'm going to get y all by itself. So I'm going to move the 4x over by subtracting it. If you remember, I cannot combine the x term and the constant, so I'm going to leave them separate. Don't forget to bring down your negative in front of that y, because we will then divide everything by -1. So this equation is actually y equals 4x plus 1. Okay, so let's graph that now. I'm going to graph it in green. Go up 1, and I would go up 4, which is off my graph. That's okay, I'll still put a point where it would be, and over 1. So I'm going to do opposite, down 4 over 1. Again, we are looking for the one, the only, the point where it crosses, which was right here. That is the solution to our system. And again, be careful when naming your point. It's always x comma y. So it's going to be -1, -3 would be our solution. Now, how many solutions does this have? 1, because most of the time it is going to be the one, the only point where they intersect. However, there are a few special cases, so let's look at some of those. All right, I'm going to graph this first one. It's already in slope-intercept form, so I can graph it right away. So I'll start at 1, and I'm going to go up 1, right 2, up 1, right 2, or down 1, left 2, down 1, left 2. Again, try to get as many points as possible. All right, the next one, notice, not in slope-intercept form. It's actually in standard form here, well, close to standard form. All right, I want to get y by itself, so I'm going to send the -x to the other side by adding it. I'm even going to put a 1 in front of there so I don't get confused. So I'm going to have 2y's equals, don't want to put them together, I'm going to put the x term first, so it's mx plus b. So 1x plus 2. All right, now I got to get rid of that 2. So I'm going to divide everything by that 2 to give me my equation in slope-intercept form of y equals 1/2 x plus 1. Huh, what do you know? Let me graph that one. So I'm going to start at 1, go up 1, right 2, up 1, right 2. Oh my goodness, what's going on? Usually, I have one and only one solution. So I guess you have to ask yourself, where do these lines cross? And the answer is everywhere on the line. Like every single point that is on that line, even the decimals, those are all solutions. Okay, we say that there are infinitely many solutions. You guys have seen that before. There are infinitely many solutions, because these lines are the exact same. Now, unlike equations where every single answer that you can think of is a solution, these are just the ones that are on the line. So if I chose the point 3, -2, is that a solution to the system? No, it's not. Again, if I chose the point 0, 3, is that a solution to the system? No, it's not. It has to be on the line. The reason why that it still is called infinitely many solutions is because this line is extended and it will go on forever. So there are an infinite amount of solutions, but it still has to be on the line. All right, last example here. Again, I'm going to go ahead and graph the first one. So go up 2. My slope is 2 over 1. So rise 2, run 1. Go opposite direction, so down and left. Again, the second line here is in standard form. So I'm going to get the y term all by itself, subtract 2x to send it to the other side. And we like to write the x term first, so negative 2x plus 1. And then to get rid of that negative in front of the y, we're going to divide everything by negative 1. So our equation is y equals 2x minus 1. So I'm going to graph that one here in purple. So go down 1. And we're going to go up 2, right 1 with our slope. Or down 2, left 1 to draw our picture. All right, so again, the solution is where the two lines cross. So ask yourself, where do these two lines cross? Well, there's nowhere on our graph. Will they ever cross? And the answer is no. So what do you call it whenever you have lines that won't cross? It is called no solution. Again, you guys have seen that before. You can write no solution. I'll put the word no there, but remember you can always use this symbol that means no solution. And these lines, if you remember from last chapter, are parallel. And what makes them parallel? They have the same slope, but they have different y-intercepts. So anytime two lines are parallel, we are going to have no solution because they will never cross. All right, and that is it for our lesson. The homework tonight is a worksheet. So check Schoology to see that worksheet, and I'll also put an answer key on there for you so you can check your answers afterwards. All right, hope to see everybody soon. Bye.